right, everybody, welcome to Connector Care Demo. Now, believe it or not, this is probably one of the most important things in this entire RF microwave course. Luckily, we have some help. We have some backup here. Mori Microwave, they sent us this, where we have a Type N connector gauge kit. This is digital, so it comes with two of them. Whereas many times if your lab might have a single analog connector gauge kit to use to gauge your connectors. So what makes connector care so important? As we mentioned throughout this, we're trying to avoid things like standing waves and insertion loss and return loss, right? Your interface is your connectors. Whether it's something like this, that's an N-type, male, or we also have N-type female here. And then on the other side of this one, we have a APC7 or a 7mm. And this is a sexless connector. So in general, as you're coming up to a test, because we want to avoid, for one, damaging our connectors, both on our devices under test as well as our standards. Some people forget these things. Imagine this. We have a connector that you're using maybe for something like this, like a directional coupler, and you need to utilize it with your standards. You're testing it or whatever in your calibration lab. You don't want to take your nice connectors and cables and just jam it onto that device under test without performing some sort of inspection and general connector care. When an item, a device to be calibrated comes in, you don't know the condition of their connectors. It doesn't matter what kind of customer they come from. I've seen really good labs have connectors that fall apart. It happens. It has nothing to do with good or bad or anything like that. It's over time, some of these components can come apart. This includes when you're looking at your own standards. And when I'm saying devices under test, it doesn't have to be passive. If you have a signal generator, do you know how many times in the military I've noticed, even though it's a part of the procedure, they will skip the gauging of connectors using one of these kits. They'll skip the gauging of connectors on the actual signal generator or spectrum analyzer. So you want to make sure you check all connectors before every test. That's by the book. You want to, at bare minimum, visual inspection if you had just previously tested the connector. So first things first, I'm going to do a visual inspection of my connector. I'm just using this male-to-male connector provided to us by Mori Microwave to show this initially. But I'm going to do a visual inspection, making sure that I don't see any contaminants, that the pin in the middle is not bent or skewed to either side, and that I don't see anything generally wrong with it, like that I don't see it protruding over the top here just from looking at the side of it. Now, we don't want to gauge it only by external visual. We also want to get under magnification. So you would have some form of magnification. Sometimes that would be the form of maybe a side magnifying lamp that can come over the top. Maybe you'll have a visor of some kind that will come down, but you need to make sure you make a good note if there's any major gashes or there are huge holes or anything really busted up on the inside, even considering down into the middle. You really have to do a thorough inspection. As we mentioned in the lecture for connector care, what's the risk is damage. And it's usually the male side damaging a female pin and breaking those apart. So that's why it's so important. Even your own connectors as a standard, your laboratory, you want to make sure that you're checking them between every test, because we have seen it. If anything is happening where you're using anything but the turning component or something is loose from a previous technician, you can have these parts falling out or falling apart. So after our visual inspection, now we're going to want to clean. We're going to use isopropyl alcohol. Absolute alcohol is preferred. All right, absolute alcohol. Now you might have something like these in your lab that will have the alcohol in it. And then we're going to use lint-free, as you can see here, lint-free Q-tips. Now there's a problem with a lot of these Q-tips that we get though, where this is too large that if I start putting this here in the middle, as you can see, if I start jamming this in, it's going to push the pin to one side or the other. Now there's a few ways around this. You can use pliers of some kind. You can take some of this material off and really squish it down. Or you can find ones like these where they're really small and have very minimal, still lint free on this, where I can very lightly get around that. And I'm not doing any damage whatsoever. I'm not going to bend anything. I can get around this middle connector. Same thing with your 7mm here. The interface is flat here. So you're going to want to take something a little bit larger and actually go across your mating surfaces. Now, if you have the tool, you need to remove the collet in here. And that is something that I will show you here up on the screen, where you remove those so that you can also clean around the center. And the nice thing is these smaller ones can really get around in there. So now that we have this sufficiently clean, now we need to gauge the connector. Now I'm going to put up on the screen the tolerances, and you are going to, I'm going to pause in between each measurement, and you're going to say to yourself whether or not it passes or fails, and then of course we will let you know. So as we're going into this, I want to show you where to find the references here. Again, you need to make sure you're familiar with the connector that you're using. So here I'm going to show you up on the screen. I typed in up here Mari microwave connector tolerance chart, and this actually gives you a connector gauges and connector gauge kits, which is very helpful. So you can see this is a data sheet for all of these different types. Now, keeping in mind, this is Mari Microwave's version. Okay, this is Mari Microwave's tolerance chart. And I'm going to come all the way through here. And here you can see the metrology grade type N digital connector kit. Look familiar? And so this is what it looks like, but it also tells you, where not to rotate, where to grasp, when you're holding things. But then when you also come down here, it will give you your gauge assemblies and its measurements resolutions. And here is the chart that we're going to be using for this training. Okay, so this is when I pull up tolerances, when I put those on the screen, this is where they're coming from. Note we have Mari High Precision, and this is generally what we're going to be using today. And here you have your A component and B component. So here you see your A component and B component and what those things mean and where you want your gap to be. And so here you see what the nominal is on both of them. And that's what our setting, our standard that I show you, they actually get calibrated. The standards included, the little standards, they get calibrated, and that's what they're calibrated to. So here in the first one, you see A, so that's for our male side. This is what our nominal is, and then plus or minus from that. And then this is the plus and minus for the female side. Now, the thing to keep in mind is looking at this, we have a plus value and a minus value. And you're going to want to keep that in mind when looking at your gauging. Am I using a female side or the male side? Now, something else I want to point out is that you notice here some of your mil class standards, class 1 and class 2. Many times this is going to be what you have just strewn about in your lab. You need to be sure though, but you notice these tolerances are a little bit wider. We only have 2 zeros before the measurement, where here we have 3. So keep that in mind as we're going through the gauging, that if you're doing something different, you're going to have different tolerances here. So in this kit, we have two different connector gauge kits. And this is a N-type connector gauge kit, where you have a female and a male side. Now, we also have 2 standards here, where we have an M on here. You can see we have an M. And on this one, we have an F, meaning these are the standards to 0 these. So taking this one off first, because we have a male here And we are testing a male connector. So turning this on, remove our cap. Now the male side, we're going to want to screw this on until we're getting relatively tight. And on this, we have our torque wrench here. Now you notice on a breakover wrench, we have a side that's higher than the other. Like if you notice, if I turn this around, it's angled off this way. So this is the proper direction. We would want to turn this direction. Now to show you, we would want to brake until here, but not brake all the way over. This is incorrect. We do not want to brake all the way over. We want to just get to where we have movement on the braking part of the wrench. Notice how I'm holding on this band right here, where on this band is the torque spot. If we remember from our torque section, this is where we want to apply the torque. And this is a 12 inch-pound, which is appropriate for our N-type. Now, hey everybody, real quick thing from the editing desk. You'll notice on this first example, I grabbed from the top of the gauge, and we just wanted to point out that technically, this is demonstration purposes only, but technically you wouldn't grab by that top. You'd want to grab by the collar, as you see on the second demonstration. Just wanted to make sure to point that out, that do not do that in regular practice. That was just for demonstration purposes only here. Thanks. Now we want to come on here, and we know we want to come the direction. So if this is the tightening direction, we want to turn it this direction. And again, from our torque point, only slightly braking over, that is how we know we get the proper torque. Now this one's zeroed because I already had it zeroed before. So forgive me on that. You're not gonna, on the next one, I'll make it something weird. In fact, here, I'll for instructional purposes, I'm gonna make sure that this is set off. So when we put our 0, so this is our standard that we're putting on here to set this as 0, which would be in this standard is setting it to what we want it to be. We want our pin depth to be this depth. Any variation, so that's why we're zeroing at that, any variation either in the positive or negative will be what we're looking at, the deviation from this standard. So as you can see here, we have a measurement. We want this to 0 with this on here, and we're gonna tighten this. So going over, but not totally breaking over. And then we're gonna hold this origin so that we're now zeroed. So now we have a good 0 for our male connector. So now we can put on one of our male connectors that we are testing. So I'm gonna put this on and I'm going to torque it down again, okay? Pulling. See, too far over. So because I clicked over, I'm actually going to loosen it again and retorque it. And here we see 0.0015 inches. Looking at the tolerance, is that in tolerance or out of tolerance? If you said out of tolerance, you got it. So there you got a good look at the male. So let's do some female tests here. So here we got a female connector, and it would be the same thing with our lint-free cotton swabs getting in there. Now we're doing a visual inspection to make sure that that center post, you can see how that is split into 4, and we want to make sure none of those are pushed off in any specific direction or all of them spread apart. We want it to look just like it is right now. And when it's perfectly in the center, if you think of concentric, this is concentricity. So where it is equally in the middle from all sides. So same thing here. We have our female, all right, our female standard, and then our connector gauge here. Go ahead and take this off. We're going to turn this on, and I'm going to give it a random 0 so that we can have an adjustment here. As you can see, so this is actually set to what the nominal is. So this is what you want it to be exactly. Now remember, we're turning the turning component. We turn the nut, nothing else. And so on this, we need to hold this, but also do our torque. And if you notice, we're turning this direction. So we would be going here with this, but then they also provide this 9/16 wrench so that we can hold it steady here. I'm going to hold it this way, and let's get this thing torqued. Notice how I'm still holding here. I'm keeping this set. And so now we want to 0 because this is our standard. So this is set for exactly the nominal. Now we're going to put our device under test. And again, this is my preferred method right here, where I hold. So I'm going to hold here. Okay. Go until we get our tightness here. Okay, so there's our measurement, negative 0.0069. So is that good or is that bad? If you said out of tolerance, you got it. So from those examples, I hope that clears things up for you if you have to test any of these. The important thing to remember is that you need to check your tolerances based upon the manufacturer of the connector. We have seen in the field different manufacturers have different tolerances and specifications. So just make sure that you have the correct specifications for your test. In this case, we're using Mari pretty much all the way around. But for instance, here's a good example of a TI where we'd be testing both sides, right? For an attenuator, we'd be testing our male side and our female side, but we'd also want to clean these both before proceeding. And also with our cables that we're using, especially cables, I should say. And the reason for that is because cables are used and taken off and twisted and pulled every test. And so they have a greater propensity to get used and abused and have the chance to fall apart. So make sure every test that you're going through, you're checking the pin depths on both female and male connectors on both your device under test as well as your standard, and making sure that you're also cleaning these things. And I always tell people, just based off of experience, I did this a lot for the Marine Corps. I have seen connectors that I'm using for one device under test. I clean everything, I do that test. I put in a new device under test that I just cleaned, go through everything. There are times I've had failures that if I go back through and clean everything after that previous test, and I go back through and clean everything again, then I have a pass. So you really cannot count every time on, hey, I just cleaned these. These are all going to be good. Sometimes just you putting things on and off, you're going to have shavings come off, things microscopic that you might not be able to see. So the best scenario is to clean after every application. One thing I wanted to mention, as we are using our absolute alcohol to clean our connectors, an important note here is that you do not want any residue. If you use enough that there is some left over and you need to dry that, you want to use canned air, not shop air. And that goes especially for any standards or equipment. Do not blow air into your equipment, devices under test, anything. Behind those connectors, you can damage things with too much PSI. Now, if you're in a lab that does microwave calibrations, you're going to have these connectors around. And these are called APC7 or 7mm sexless connectors. As you can see here, this is two connectors that I'm going to connect up to each other. How do these work, right? Well, see, these, you have a spinning nut on top. If I go one way, nothing happens. If I go the other way, then you're going to have threads pop out. So there's two states to these connectors. Completely extended, meaning you spin it and it doesn't come out anymore, or completely retracted, meaning you're spinning it and it cannot retract anymore. Those are key. There is no in between with these connectors. So I want one going outwards, extracted, one retracted. Okay, so I have a retracted and I have one that is extended. And then the retracted, I'm going to turn this nut onto, and we want to keep this stable. We don't want to turn anything but the turning component. So notice how I put that on there. We would torque here. All right, we would torque here, but notice this stays loose. Do not tighten. If you tighten this, and thinking about the type of connectors these are, they are flat together. If you are pushing this one, if you feel like, hey, I have to have these tight, if you tighten this, you're actually pushing those apart. You want one completely retracted, right, or fully extended with this loose, and one of these tight, and then torqued. Obviously, I don't have the proper torque wrench here for that, but that is something I like to show, and would hand these around to you if we were doing this in person. But just one more time, and here I'll retract it again. So these are completely retracted. Now I'll spin this until I got extension, complete extension. It won't come out anymore. This is complete retraction. It won't come out anymore, or go in anymore. And then I hold these put, turn only the turning component. This one stays loose, and that is properly connected as long as we torque properly as well. There are different connector gauges for these, like the 2.4 here, or even these, the 7 millimeters. So make sure you're checking your connectors, and that means all of them. One other thing I'm going to point out, and you'll see this a lot, especially in our training environments and whatever, here where I have, I'm not necessarily set up for microwave calibrations. You really don't want to be setting your connectors down like this either, where you are completely, and I can show it back over here, where it's just standing up and down on its connector on either side. This is bad for the connector. And you'll see, even us as instructors, with some of this equipment that we're trying to work with people real quick. If you're in the mix, if you are doing calibrations, you need to make sure that you are treating these and putting the connector covers on them and placing them down so you're not damaging the interface portions of the connectors. So that's pretty much it. A couple other tips. Make sure that you're supporting your connectors with things like this, where you have support underneath any long things that are hanging out, like sensors or whatever. You need to have something underneath them. These were like $12 off of eBay or off of Amazon, or like this blue one here. I mean, these aren't expensive, but these will save your sensors, your connectors, and things like that. And then, of course, don't forget things like a connector saver, something that you put over your standards so that you are connecting to a port outside of your actual device, that if you break that one attached to your standard, you have to send it out for a few weeks or tens of thousands of dollars for repair. Just make sure that you are taking care of your connectors. It is that important. So that's it for connector care. Thank you again for watching. If you have any questions over anything that we went over, please reach out to us at support@signcalibration.com. Thanks for watching.